I want to talk about heat transfer in the context of something that's very important to you and that we'll have several problems on in the homework, and that's your home. And so, how does that work? Well, this is going to sound very physicky, and we're going to get down to more details. But the rate at which energy goes out of your house, right? So, or out through a surface, this Q over T is heat over time, is proportional to what's called the thermal conductivity of the material times the area. So this area you could think of as the area of a window. You could think of this as the area of a window, and then it's just the temperature inside minus the temperature outside, divided by how thick the window is. So the area of the window divided by how thick it is, and here is the conductivity of the glass, thermal conductivity of the glass. All right, so you can see if there is a 10 degree, and this is Celsius by the way, typically, if there is a 10-degree difference in temperature, then heat flows out at one rate from your house. If you double that, and now there's a 20-degree difference in temperature, then heat flows out of your house twice as fast through that window. So this is why changing your thermostat, like right now when it's not very hot or very cold, trying to keep your thermostat so that there's not a big difference between the inside and the outside, really slows down the rate at which heat leaves your home or comes into your home. All right. All of this in terms of commercial stuff we think of in terms of what's called the R value. So if you go down to the hardware store to buy insulation for your house, or you are looking at, should I buy this kind of window versus that kind of window, what you're looking for is the one with the best R value. The R value is nothing other than the depth of the material, how thick it is, divided by its conductivity. So a standard glass window has an R value of about 1. A double pane window with an air gap in the middle has an R value of about 2. If you put a nice dry gas in between like argon, you might be able to get it up as high as about 3. So let's look at this formula in terms of the same stuff, except we're using R value instead of conductivity and depth. All right, so now the rate at which heat flows into or out of your home depends on the surface area we're talking about. So if we're talking about through a wooden door, or we're talking about through the area through a window, that's the area you're talking about there. Use the R value for the door or the R value for the window, and this is the temperature difference between inside and outside. All right, and this gives you the rate at which heat is flowing out. Now, if you look for insulators like standard fiberglass insulation, you're going to have R values around 4 or 8 or 12, depending on quality of the materials and depending on thickness of the materials. You can use styrofoam, closed cell, open cell, all kinds of things that can be used for insulating material. And when you get out there, the key feature on all of them is going to be this R value, because you can see a larger R value slows down the rate at which heat leaves your house. Hopefully that makes sense. And if you were to go to Home Depot and try and look some up, or to Lowe's and try and look some up and different installations up, you're going to see this R value all over the place. The R value of your Yeti cup, if you have a Yeti cup, is probably around 30. It's a pretty good insulator. R value of a Yeti cup, probably around 30. All right, that's it for now. There'll be examples of problems on this, and there'll be some problems for you to work on this, and hopefully that'll all put it in a better context and help you understand where this becomes important. I will see you on the next video.